Welcome back to Basic Advanced Math, channel where I take you through some complex math and try and explain it to you in a way that you can take it, move on into the world, and apply it yourself in an understandable way. Today we are beginning integration by substitution. I didn't write out the whole words because I didn't want to. Now, integration, this is going to be a major part of calculus BC. If there's any lesson that I want you to get something out of, it's this one right here, because this is going to be the foundation for everything that you do for at least a quarter of this class. So for integration, there are going to be a few key formulas that you're going to have to know by heart or put it into your notes in a calculator maybe, wherever you're going to be able to pull these out of anywhere and be able to apply them to whatever you're doing. The first one is going to be the integral of 1 over x dx, that equals natural log of x. We did this earlier in the reverse. We did the derivative of natural log of x equals 1 over x. It's just reversing it. That one's pretty easy to remember because it goes both ways. The next one, integral of e to the x dx equals e to the x. It's the exact same thing. The derivative of this is that it stays the same no matter how many times you integrate it or derivate it. That's it. The last one that you're going to need to know is integral of a to the x dx equals a to the x over natural log of a. This works based off of just the integral rule, derivation rule. You could believe me or not believe me. I would suggest that you believe me. Of course, you need to know the basic sine and cosine, how it follows sine to cosine to minus sine to minus cosine. We're going to be using that as well. But other than that, these are the foundations of integration that you're going to be using. And now I'm going to show you how to integrate by substitution right here. So we are actually going to jump straight into an example. The easiest way for me to teach you how to use substitution is to jump straight into an example and show you what to do from there. So I'm going to write one real quick and we're going to get into this. Here we go. We got our example right here. It may look kind of scary to say, how am I going to integrate this? I don't even know how to integrate one of these terms. Maybe you do. Hopefully you do. But either way, we're going to show you how to get through this. So here's what you're going to do. dx, of course, you know what that is. That's required for integration. You don't really have to worry about that when solving for whatever you're doing. What you do have to worry about is these three terms right here. Now, when you're integrating by substitution, you're going to be substituting one of these terms for u. And when you do that, you want to try and use it to your advantage to where you can substitute one of these terms and at the same time get rid of one of the other terms. Now, when you substitute a term, this is going to sound kind of confusing, but you'll see in a minute when I go through the example. When you substitute a term, you're going to take the derivative of that term and divide the equation by the derivative of the term. So what we were trying to do is to find a term that's derivative is already in the denominator of the function. This may sound kind of confusing, but I'll show it to you right now. So which one of these? We'll go with x squared. You can see that x squared, the derivative of it is 2x. 2x is in the numerator of the equation, so we know that when we divide the equation by 2x, the 2x is going to go away, become a 1, and is gone. So the term that we're going to substitute is u equals x squared. U is just the term that you use to substitute. It could be any letter, but it's standard to be u. So that's what we're going to use. And we have our u. What are we going to do? Like I said, we're going to take the derivative of that. We're going to take the derivative of u and then solve for du, which is just going to be dividing by whatever the derivative is. You'll see in a minute. So we have u equals x squared. What is du? Derivative of u is 2x dx. You can't forget that dx because it's necessary to solve the equation. Now, like I said, the reason we're going to divide this entire equation by 2x is because what you're doing right here is you are substituting this dx for this du. However, you have to find out what the dx is in terms of du. So what are we going to do? We're going to take this equation right here, and we are going to solve for dx. Du over 2. So now, what we're going to do when we substitute is we are going to substitute this dx for du over 2. Because we see that they equal each other right here from this equation. Well, the other substitution that we're also going to make is x squared for u. We're going to substitute that in there. And then when we substitute du over 2 for dx, we see that the 2x disappears. What are we going to get? Look how beautiful that just became. All of this became this with some simple substitution. You should know how to integrate this. The integral of cosine u du is the same as cosine x. It is going to be sine u or sine x. So all this is, the integral of this is going to be sine of u. So we write that down. And we are almost there. The only thing that we have left to do is substitute the u back into the equation over here. So we see u equals x squared. We have to write it in terms of x, of course, because that's how it was asked to us. So now to finish the equation, the only thing we have left to do is this. And bam, we're done. We substitute u back into the equation with x squared. And this is our final answer. That's it. I know it's going to be confusing. The most difficult part is recognizing what u is. So this is going to take a lot of practice. You need to get the recognition down of what your substitution is. Once you get that down, it's all clockwork. It's all going to get super easy. I believe in you guys. This is integration by substitution. You need to know these formulas. That's it for now. Pause for a second. You really thought I was about to do that, didn't you? This is what you cannot do. You cannot walk off all confident when you made a mistake. Every single time you integrate, what you have to do is add the plus the constants. You have to add the constant in there every single time. This is vital. If you leave that off, you're over. You missed the problem. You got it wrong. I hope you guys caught that. Other than that, this is the final answer. You cannot leave off the constants. As long as you caught that and you're able to figure out what to do, that's it. That's really all you have to do. Goodbye.